Welcome back. This is the second part. In the first part, we learned using Tiger Sense data and filter the geometry within the extent of Lubbock County. But what if we wanted to use our own user-defined study area? Fortunately, that is possible. We can ingest our data in terms of image, zip file, and Excel CSV file, and that is possible through Asset tab. Go to Asset tab, and then you'll see New tab, and if you click on this small triangle, you can see the options. So we can upload image collection, and then table upload. Table upload also consists zip files. This is because Google first introduced fusion table concept for map making. This fusion table support has been discontinued in last year. The core fusion table is still supported as a FT feature. So to upload this, simply click in here, and then you can give a name. This name should be unique. Whatever this asset name should be unique and should not resemble with the asset you already have. So I'm going to give a name, Lubbock, as a name. We don't have to worry about the other. Here let's select the feature. So L County is the folder. Here I already have the compressed zip folder, but we can also select those for DBF, which stores the data, PRJ extension store the projection information, SHX file store the index information, and SHP file store the shape information or the geometry. Here within the zip file, I have all those 4 features. Okay, our data is already ingested, and we can see here. Simply refresh it, and there we go. We have our data here, and if you click on here, and this is the name for our feature collection. Let's copy this, close for now. Okay, last time we used a NAPE orthoimagery, and then we looked into its band information and then did available. I wanted to continue with the same data before we use Landsat. Here I have the feature data. Now we can change here. I've already copied it, so let's paste it, and then use double quote here. So with the image variable, we are storing image collection of NAPE data. Again, to get this information or the ID, simply click on the search bar, type NAIP, and then go to National Agriculture Imagery Program. And if you look at it here, this is the name for this collection. And since we are already here, let's go and look at the band. So for the band, we have R, G, B, N. These are the bands that are given to red, green, blue, and near infrared. The resolution is 1 meter. Okay. So this is the point location somewhere in the logbook so that I can zoom into that area. So this is the feature that is within the extent of logbook. For now, you can see the area is somewhere else. Previously, to filter the date, since we have the only two parameters to filter the NAIP data, one is different bands if we need to, the another one is the date. NAIP data are normally collected every other year or every year depending on the state funding. And filter date can be used for the NAIP data. In the previous example, we supplied the date here, but in this case we create the different date variable for starting date and ending date. So here with this line of code, we wanted to filter the date, filter the image from 2016 January 1 to 2016 December 31st. NAIP imagery is not collected every 15 days or 15 or 16 days or every month. The one set of data collected every year or every other year depending on the funding. So although we define the larger time range, but it will only give you one set of data for that reason. Although the output does look like the image is mosaic, but they are in tiles and it seems staged when they displayed, but they are not actually mosaic. So we can mosaic them using .mosaic notation, and to clip within the extent of logbook we can use clip function, and extent is the geometric extent of logbook, the data we just ingested. So with the map.center object, it zooms at 8 level within this point location somewhere in logbook. So the script error line number 5. Okay, let's center it and get the geometry and coordinate information, and finally display it using false color composite. Every other line of code I wanted to comment it at the end. So let's run it. As you can see, within that point location the map is zoomed and we have the composite layer. So what is happening here is, from those vast collection of data available throughout the United States, we select all of them and then filter by date, and we mosaic it first and then clip within the extent of logbook, and we displayed using the false color composite. So let me uncomment it here. So let's do some band calculation. So we know the equation of NDVI is NDVI equals to near infrared minus red over near infrared plus red. This is the equation. So we can use individual band and then do the band mathematics. Here with the first I select the near infrared band and then give a name NIR, and then select the red band and then give a name red. In the numerator of NDVI, the red band is subtracted from near infrared, and that information is stored in numerator or num variable. Denominator information is stored in the deno variable. And finally, we can calculate NDVI by dividing numerator by denominator. This is the first approach of defining NDVI. Let's give a name NDVI1 and then divide numerator by denominator. Another approach to calculate image or band mathematics is using the expression command. So with the image we have the filtered image, you can use expression and then define the expression, and this is the expression within the code which indicates the NDVI. But in nape imagery there is no NIR band. NIR band is referred or denoted by N band. So this is easy for us to understand the equation, but we can select and redefine. We can do that using the image selection. So we select and then define. We can do that within the curly braces. And once we are done defining red and near infrared after selecting those band, we can close the parenthesis for the image, the expression, finish the command with the semicolon. Since this is the second way of looking at the NDVI, I am going to give a name NDVI2, and then before we display it, let's calculate the NDVI from another approach. So normalized approach of creating indices, it's so famous and so frequent. It has its own function in Google Earth Engine. To understand this, go to docs and then type normalized, and then you can see the function. It uses normalized difference function and then takes band names as input arguments. Band names are normally from the list, so that means to select them we need to use the square bracket. So let's use the normalized difference function and then select the first argument and then second argument, and then give a name NDVI3. So now we can add all these 3 NDVI types and display them. So normally for the map, the first argument is image, second argument is visualization parameter, and then third argument is the name that you wanted to display as a layer. As the NDVI values, minimum values -1, theoretical minimum value is -1 to +1. I wanted to set them using the blue to red color gradient. Let's see how it looks like. Let's run it. I have not covered this projection information. Here I've commented out, this can be supplied when we export our image. So when we export after the classification, we will cover the projection system there. So now we have the NDVI displayed, and we can toggle those buttons and select whether we choose to display them or not. The first NDVI and NDVI1, that doesn't look that good, but the color gradient version look good. You can change the visualization parameter, adding the color here. If you want another extra color somewhere, I can simply select it here and click OK, and then apply it if you wanted to. The third way of calculating NDVI, or the normalized difference function, is only applicable when the equation looks like the equation of NDVI. For other indices, it doesn't work. So we may have to rely on the expression. For example, here, this commented portion is to calculate modified soil adjacent vegetation indices 2, or MSAVI 2, and this is the equation. Selecting band for NDVI, we can select this red and near infrared band. Again, MSAVI is also based on only 2 bands, but we have very different equation. We have square root, we have power, and multiplication. So this is just to show you how versatile the expression is. Finally, there is a challenge I want you to do by yourself. Just give a try. Select Landsat at any Landsat 4, 5, 6, 7 or 8, anything would be fine, and clip within the extent of logbook and select the bands and calculate NDVI and NBR. So if you don't know NBR stands for normalized burn ratio, and it gives the burn severity information. The band combination for NBR is different for Landsat 4 and Landsat 8. So accordingly, I have the equation for that. Find out the equation for NDVI, calculate it, and display it. This is it for this video. I will see you in next time.